In this video, we will learn about Flip Flop Excitation Tables. So far, in the previous videos, we already learned about Flip Flop Truth Tables and the Characteristic Tables. The Characteristic Table is useful for the analysis and it defines the operation of flip-flops. It specifies the outputs only when the present states and the inputs are known. During design process of a sequential circuit, we have a transition from present state to next state and we wish to find out the input conditions during that transition. So for that reason, we need a excitation table. Here, a table that lists the required inputs for a given transition from present state to next state. Such a list is called an excitation table. It can be derived. So here we can derive the excitation tables for flip-flops from their truth tables. Firstly, we will learn about SR flip-flop excitation table. Coming to these SR flip-flop excitation tables, we are having 4 columns. Q of t plus 1, set and reset input pins. Here, Q of t is the present state before giving the clock pulse. Q of t plus 1 is the next state after giving the clock pulse. This excitation table can be obtained by using this truth table of SR flip-flop. Here also, this truth table is going to consist of set input pin, reset input pin and the output Q of t plus 1 after giving the clock pulse. In this table, it is going to consist of Q of t. It is indicating the present state before giving the clock pulse. So, coming to this excitation table, we are having 4 transitions. 0 to 0 transition, 0 to 1 transition, 1 to 0 transition, 1 to 1 transition. Firstly, we will consider 0 to 0 transition. This one. Here, in this transition, the possible input conditions we may find like this. When Q of t, this one, to Q of t plus 1. The transition from 0 to 0 can be possible in the input conditions for 0 to 0 input conditions. When set input pin is 0, reset input pin is 0, it is saying from this truth table Q of t, the present state is 0 here, the next state is also going to contain 0. So this is one of the input condition. And the next state is 0 in the input condition from set input pin is 0, reset input pin is 1 here. So from this, we may easily say the set input pin will be 0 and the reset input can be don't care. It can be 0 and it can be 1. So in this 0 to 0 transition, the set input pin will become 0 and reset input pin will become don't care. So it is going to contain a bit, either it may be 0 or it may be 1. Now considering the second transition, 0 to 1 transition. 0 to 1 transition. This possibility can be obtained in the input conditions from 1 to set input pin is 1, reset input pin is 0. Set input pin is 1, reset input pin is 0. So here the set input pin is 1, reset input pin is 0. Now coming to this third transition, 1 to 0 transition, the next state is indicating it is 0 means the set input pin is 0, reset input pin is 1 here. So the set input pin is 0, reset input pin is 1. Now coming to this fourth transition, 1-to-1 transition can be obtained when set input pin is 0, reset input pin is 0 and set input pin is 1, reset input pin is 1. So it will indicate that set input pin can be don't care and reset input pin can be 0. We may consider. So here set input can be don't care, reset input can be 0. So this completes the explanation of excitation table of SR flip flop.